Experiment 3, DC circuit. Okay, this is our team. The first is Nur Salsabila binti Nur Izan. The second is me, Nur Ali Adrana binti Muhammad Izhan. And the third is Nur Aina Natasha binti Mishariman. Okay, next is the procedure. The procedure for part 1, measuring the current and the voltage in simple DC circuit. First, the first simulation website link was clicked. So we just click this link and we got this. After that, the battery symbol in the bottom right and show current conventional was clicked. We need to change it into conventional. The simple DC circuit was created by inserting a battery 10 volt, resistance, switch and wires as shown like this. The voltmeter from the right second box was clicked, and the two terminals with the endpoints of the resistor were connected in parallel. The ammeter was connected to the circuit. The voltmeter value V1 and ammeter value A1 and resistance value R1 were recorded in data analysis table 1. Then the voltage of the battery was changed to 20 volt for the second test trial and 30 volt for the third test trial. The step 3, 4, 5 was repeated carefully. So we just need to switch off the switch. And this is the 10 volt. We just need to change it into 20 volt. So we just got this. And lastly is change into 30 volt. Okay, we got this. This is the procedure for part 1. Okay, next is procedure for part 2, series connection of resistor. It's just the same thing from part 1, the procedure part 1, but we just add another resistor in this circuit. The power supply output was adjusted to 120 volts and the two resistors were set up as R1 equals to 20 ohms and R2 is 30 ohms. The voltmeter was connected across the resistance R1 to measure the voltage V1. The voltmeter across the resistance R2 also was connected to to measure the voltage drop V2. So after that, we just close the switch and we got like this. The voltmeter was connected across the water supply and across the resistance to measure the voltage. So we need to find the V power supply. So V1 plus V2. 48 volt plus 72 volt. So we just get 120 volt. Okay, next is the electric current was measured and recorded using the ammeter before R1, between R1 and R2, and after R2. So this is R1, 20 ohms, R2 is 30 ohms. So this is ammeter before R1, this is ammeter between R1 and R2, and this is the ammeter after R2. So we just need to switch off this switch. So we got this. Okay, this is the procedure for part 3, parallel connection of resistor. The circuit was set up like this. So the battery is 120 volt. We can adjust like this. Okay, the R1 is 20 ohms, R2 is 30 ohms. So we need to put the right like this. Put this wire like this. This. After that, we just switch off the switch. So we got the voltage for R1 and R2. After that, we need to measure by using the ammeter. So this is the first ammeter, A1. A2 and A total. So we just close the switch. So we just got this. The A1, the emitter 1 is 6 ampere and A2 is 4 ampere. So the A total is 10
Okay, next we
ampere.
move to the result and analysis data. Okay, for the part 1 experiment, that is measuring the current and the voltage in DC circuit. Okay, in this part we notice that the resistance value was constant and the voltage and current value was changed. So the graph we have here is the current was directly proportional to the voltage. It means if the voltage was added, the current will increase too. Okay, next we move to the part 2, that is the series connection of resistor. In this part, we notice that the current was constant, that is 2.4 ampere, and the voltage and resistance value was changed. The graph we got here is the resistance, the voltage was directly proportional to the resistance. Okay, and the last part, part 3, that is about parallel connection of resistor. In this part, we notice that the voltage was constant and the resistance and current was changed. The graph we got here is if we add the resistance, the current will decrease.
Hi, my name is Nur Arina Shamitim Shariman and I will continue the discussion of this experiment. For experiment 1, we got our graph is the current directly proportional to the voltage of the battery. The transmission of charge is symbolized by current. As a result, the higher voltage of the battery provides an additional burst of energy to the electrons, resulting in a substantially faster flow rate. Ohm's law state that V equals to IR. In the graph, we got our current was increased when the voltage of the battery increased. For experiment 2, resistance directly proportional with the voltage in the circuit. The voltmeter value will increase when we add more resistor in the series connection of DC circuit, while the ammeter will be constant in the circuit. A series circuit has the same amount of current flowing through all its components. This is due to the fact that in a series circuit, there is only one channel for current flow. Ohm's law states that in the series connection of the resistor, the current flow across R1 and R2 is the same, and for the voltage value, it will be changed. Now for experiment 3, we got the graph is resistance inversely proportional to the current. The current has different value on different resistance in this experiment because each load is linked to the same supply voltage. The current decreased because there was more than one pathway to flow. The voltage across each component of the parallel circuit is the same. The sum of the current flowing via each path equal to the total current flowing from the source. Ohm's law states that I equals to VR. We got that the parallel connection of resistor will affect the current value. Current value will drop when we add more resistance in that circuit while the voltage remains constant. For this experiment has experimental error, which is misreading data and there was an error in the circuit setup. For improvement, we should be more careful when preparing the circuit and must follow the instruction from the lab manual properly. And the last one, conclusion of this experiment. In the conclusion, we can conclude that the experiment was successfully conducted because the current and the voltage of a simple DC circuit can be measured by using Ohm's law formula, which is V equal to IR. The voltage and the current of the series and parallel circuit was successfully observed by connecting the ammeter and voltmeter in the circuit and using the formula for series and parallel connection. In the series connection of the resistance circuit, the voltage was affected to the changing place of the resistance, while in the parallel connection of resistance, the current was affected by changing the place of resistance.